So okay, so Ian, did you understand what's going on? You compare the highest degree of the function. Did you write that down? Ian, did you write down whatever I write down on the board? It says horizontal asymptotes compare the degree of the numerator and denominator of a rational function. If the same degree, you look at the coefficient that's in the front, which is 4/6. And if you type in here y equal to 4/6 like this, you're gonna see this horizontal asymptote right here. The blue line. Not only blue line, if you click on the blue dots over there, you click that blue and the wave dot a little bit longer, and it will come out as dotted line. Do you see that dotted line? Can you do it on your computer or on your cell phone? You're gonna see this is a vertical asymptote. And you're gonna say, hey, Mr. Ye, you say one thing that's different. I'm gonna give you a horrible analogy. I'm gonna get canceled for it. But I don't give a shit. Okay? So horizontal asymptote is unlike vertical asymptote. Vertical asymptote is never cross. They never cross the line. So you see all the vertical asymptote is never gonna touch. Okay? So the way my analogy is this. A vertical asymptote is like the person's gay. You never have a chance, ever. Okay, so you're gonna see there's a vertical asymptote here. Where's the vertical asymptote? Oh no. Somewhere in there. I don't know where is it, but somewhere it's there. I think there's a vertical asymptote between 0 to 1. I don't know where is it, but they are for sure gay. Horizontal asymptote is different. Horizontal asymptote is like the person's like, what do they call it, bicarious? Or no? Like, I don't know, like those people like experiment both. No. Well, yes. But there's a difference between bisexual. Is horizontal asymptote is find out they are eventually gay. They have like experimental stage of their age between like say whatever, right? Between like 15 to 25, and they experiment both sides and eventually find out they are eventually gay. Do you ever seen that happen before? I know a guy like who's like 70s and he's just opened up, he's like, I'm gay. Oh. No, I'm serious. It happened, right? And some people even marry, have kids, and they say, no, I'm gay. You never seen that happen? No. Bruce Jenner? Whatever that is, right? So what I'm trying to say is horizontal asymptote, you're gonna see this point here that they are crossing that line, and it's perfectly okay. They can do it once. They can do it once. But if you see at the end, they are asymptotes. You see that asymptote is the line that would never touch. You don't care about what happened in the middle region. You only care about what happened at the end. Okay? And I don't care if you're gay or not. So that way I don't get canceled. I'm just giving an example. A lot of time, like people get confused, like why is a horizontal asymptote? They cross the horizontal asymptote. They in the middle region they can't. In the middle region they can't. Only what happened at the end. So it's end behavior. You only see what happened at the end. Is that okay? So that's a horizontal asymptote. Dotted line is because I choose to. I click this line a little bit longer. And the reason why we cannot graph a line, if we graph a line without as a function, so we want to show you that is a asymptote. An asymptote, so we can choose to make a dotted line. And you can do that every time you manipulate with decimals. So second thing, when you graph, so you graph like Nelly, never say her name, Neil. So you graph your things at like Neil, then you're gonna go back, you're gonna say, hey, that's check on my graph. That she does that. She went to check her graph, whether her graph is correct or wrong. Most of graphing question, you have to check back with decimal. Make sure, confirm that you have the same graph as them. To confirm that you have same asymptote or same everything. You can just try to graph it, see if they really become the asymptote. Okay, do you see what I'm saying? So I hear they can cross. Horizontal, they are eventually gay. Vertical, they are for sure gay. Yes.
Will it always cross like near the beginning?
Sometimes they don't have to cross. Sometimes horizontal, they are, could be like, yeah, they are gay. But sometimes they will cross in the middle part and then eventually lead to a horizontal asymptote. But horizontal asymptote is the end behavior. It's what happened at the end, all the way to the negative infinity and all the way to positive infinity. But in the middle part, it doesn't really matter because in calculus, we have different definition. In calculus, we says limit as x approach infinity, what happened? That's the definition of horizontal asymptote. In pre-cal, we just have to look at the degrees and we can find out where this horizontal asymptote is. Okay, so that we got a chance, we can go this. So hopefully I'm not offending anybody. Am I? I'm sorry if I did. I don't really care if you're gay or not. But this is 2023, so. If you have, so you compare the degrees, right? And what's the compare degree of numerator and denominator of rational functions. So if it's the same degrees, it's easy. So if they have the same degree, which is you only compare the highest one. You don't compare 2x squared, you don't compare 4x, you only compare the this part. So 4x cubed plus 2x squared plus 4x all over 6x cubed plus 2x squared minus 4. So you only compare this part. And since 4 over 6 is the coefficient in front of the highest degree, so it's 2 over 3. So y equal to 2 over 3. If you graph y equal to 2 over 3, there's your horizontal asymptote. You set denominator equal to 0, it's a vertical asymptote. Compare the degree, you're going to see a horizontal asymptote. Can you have multiple horizontal asymptotes? Yes, you can have 2 horizontal asymptotes. As many as 2, but that happened in calculus. Right now, it doesn't matter. But in calculus, you do have 2 horizontal asymptotes sometimes. B. What if the degree of denominator is larger? So degree of denominator is larger. So then if you, let's say 3x squared plus 2x plus 5, 6x cubed plus 5x plus 2, something like this. Do you see that degree is larger? Here, x cubed. Do you see that? Yeah. Degree of denominator is larger. So this is larger, right? X cubed is larger than x squared. And denominator is larger. Can you guys graph this function and tell me where the horizontal asymptote is? Just graph it by yourself. And I want you to see if you can discover where the horizontal asymptote is. Just graph that function, 6x squared plus 2x plus 5. And that 2x plus 5, it doesn't really matter. Or 5x plus 2 doesn't really matter. Only compare the first degree. Graph it and tell me if you see any horizontal asymptote. I think John Travolta is gay. Does anybody know if John Travolta is gay? He was married, had multiple kids. Oh, Shaquille O'Neal. You guys didn't know that, right? Have you guys heard about rumor about him? No? No, not Shaquille O'Neal. I'm sorry, Dwight Howard. Dwight Howard. Dwight Howard? He's a center. He played basketball. Sorry, my discussion in my class is always off tangent. Do you guys see the horizontal asymptote at this case? Do you see it or no? Yes.
I would say I greater than larger.
No, I said degree of denominator is larger. Denominator is larger. So if x cubed is on the bottom and x squared on the top, denominator is larger. Do you guys see a horizontal asymptote or no? And where they are located at? Nobody can tell me? Yes. It is at 0. So anytime the bottom is larger, it's going to be horizontal asymptote. So larger is bottom, then horizontal asymptote is y equal to 0. If you don't believe me, graph y equal to 0, and then you see, and you draw a dotted line there, and you see if that ever cross that horizontal axis, at x-axis. Try it. See, zoom in, zoom out, see if they cross it. You guys gotta actually understand that. You gotta check with decimal with your graph. See, if a degree of numerator is larger, then there is no horizontal asymptote. There's no horizontal asymptote. So there are 3 situations. If degree is the same, you got a horizontal asymptote is look at the coefficient, the number in the front. Now, when I give you homework, I don't have to give you the right order, so you have to figure out what is the largest degrees of the numerator and largest degrees of the denominator. And you gotta go check on the decimals graph. You gotta go check on the decimals graph. So we got 3 situations. One situation, same degree, is very easy. The second situation is bottom's larger. If bottom's larger, it's gonna be 0. If the numerator is larger, it's gonna be no horizontal asymptote. So sometimes you can have rational function without horizontal asymptote. Functions are gonna go straight up, and I'll show you what it look like. Let's go graph it this. I don't know. So let's graph this, and let's just change this one thing to larger here in the top. I'm just changing that to 4 here. And if you see here, there is no horizontal asymptote. This is not horizontal asymptote actually. Horizontal asymptote is they will get closer as they go to infinite. So you see that the line is actually didn't cross the middle part, yes, but it's not eventually plateau into that line. The horizontal asymptote eventually is going to plateau into that line, and you don't see that happen here. You don't see that happen here. And I believe there was a slant asymptote here. Slant asymptote is the asymptote look like a diagonal lines. This is interesting. I'm kind of interesting to find this one now. Where's the slant? Huh. It doesn't look like there's one, but there's one. Oh well, doesn't matter. We're not gonna look in detail in the slant. So we just learned how to find horizontal asymptote. So I only have a few minutes left at 8:14, so is that okay? Do you guys know how to find horizontal asymptote now? So you know how to find whole, you know how to find vertical asymptote. By the way, how do you find vertical asymptote? Well, set the leftover denominator. Okay, so write it down. Horizontal asymptote is compare the degrees. Vertical asymptote is set the leftover after you cancel, after you get rid of whole and everything, right? After you cancel all the factor, the leftover denominator equal to 0. Okay, how do you find the whole? The whole is the cancel factor. So cancel factor equal to 0. So if you factor something, you canceled it, that cancel factor equal to 0 is going to get x. Now, how do you find out the y? To find the coordinates, of the whole, you plug in the x into the leftover function. You plug into the leftover function. Which is, you did that yesterday. Once you got something, you plug in. So let's go look at this one again. So C says f of x is equal to x squared minus 25 over 2x cubed minus 50x. And I'm going to say times by, I don't know, x minus 2. So we have kind of changed your function yesterday. And if I multiply this x minus 2 on the bottom, I'm going to get, I don't know, whatever. Do you see any horizontal asymptote? Are you sure? Annika? It should be 1 and y equals 0. Why do you say that, Annika? Denominator is the greater, because it's actually denominator is x to the 4th. Do you see it's x to the 4th? Because x to the 3rd times x to the 1st, that's equal to x to the 4th. Does that make sense? On the numerator, it was only x squared. So which degree is larger? Bottom one. So there's horizontal asymptote, right? There's a horizontal asymptote. Is y equal to 0. Now I can simplify this, x plus 5, x minus 5, over 2. If you factor out 2, x, that's going to be x plus 5, x minus 5, and x minus 2. So what happened? If I cancel, I have 1 over 2x times x minus 2. Do you see that? So the cancel factor, if you set that equal to 0, I'm going to plug in back in to figure out what the whole is. Where's the whole? 1 over 2 times 5 minus 2. I don't know what is that. 1 over 30. And there's another one, 2 times negative 5 minus 2 is equal to 1 over what? I don't know, what is that? 70 is positive or negative? Positive. Yes. So you have a 2 asymptote on the different places. How many vertical asymptote you have? Which 2? Good job. Which 2? No. Yes?
0 and 2.
0 and 2. Did anybody see that? Brandon, can you explain to everybody why it's 0 and 2?
Because the end product of 1 over 2x.
Yes. So you will have a graph that's based on those things. You will have two asymptotes, one side 0, one side here, and one side 2. And we're gonna figure out the rest of the graph tomorrow, but there's a hole somewhere out there. Yeah, you were able to respond to the question. You just had to stand up and stay awake, unfortunately. And you also use the restroom too, so. Yeah. It's like 4 of them.